To measure the heat capacity of an object, you have to put it in a thermal contact with another object whose heat capacity you know. So for example, like in this example, we know the heat capacity of water. It's 1 calorie per gram Celsius, meaning it takes 1 calorie of heat to change the temperature of 1 grams of water by 1 degree Celsius. And so we take a chunk of metal whose heat capacity is unknown, or whose specific heat is unknown. We put it in boiling water at 100. Then we quickly transfer it to a cup, styrofoam cup, which has 250 grams of water at 20 degrees. We could measure the temperature, and then after a minute or so we measure the temperature again, and it was 24 degrees, assuming that during this time no energy has been transferred between the cup and the surrounding. The heat capacity of the cup itself is negligible, which means there's no heat lost to the cup itself. How much heat is lost by the water? Okay, so they mean the initial water, because the cup of water went from 20 to 24, so the water in the cup actually gained heat. It didn't lose heat, but the boiling water, where the chunk of metal was first immersed, did lose heat. And if we want to find how much heat is lost by the water, we could start by the definition of the heat capacity, which is the amount of heat needed to raise a temperature for every 1 degree temperature change. So for part A, we know that the specific heat of water, which we know, by the way, is Q divided by delta T, and Q is the heat that we are trying to find. So that means and now this specific heat or the heat capacity, we could replace it by a more useful quantity, which is the specific heat capacity, and that's per unit mass, because that's what we know about water. So we can substitute C, small c, to equal C over M. Okay, and in other words, big C for water is equal to small c for water, this is big C, times the mass. Okay, and so then if we plug this back into the equation, then we get Q equal, this is where our famous Q equal MC delta T equation comes from. CW. Okay, C for water. And so I know that the mass of water is 250 grams. I know that CW is 1 calorie per 1 gram Celsius, and I know that the change in temperature, it went from oh, by the way, I failed to mention that the same heat that was lost by the water to the metal will actually be the same amount that was lost or that was gained by the water in the styrofoam cup from the metal. So because I don't have enough information about the boiling water other than its temperature, I could use the change in temperature in the water in the styrofoam cup to figure out how much heat was gained by that water, and that would be the same amount that was lost by the boiling water to the metal. Okay, and so in that case, this would be the change in temperature of the water in the styrofoam cup, which would be equal to 24 minus 20, and this is Celsius. So Celsius cancels, grams cancels, and you could see we will get the answer in calories. So this is 250 times 4. So this looks to be for 1,000 calories. Okay, so that means the heat that was lost by the water is 1,000 calories. Okay, how much heat was is gained by the metal? Well, it would have to be the same, correct? It has to be the same because that's what I just explained. Whatever was gained by the metal from the boiling water was delivered to the water in the styrofoam cup by the metal. Okay, so for part B, so for part A, this is the heat lost. Okay, for part B, Q gained by the metal, so this is Q for the metal, has to also equal 1,000 calories. Okay, part C, now it asks what's the heat capacity of this chunk of metal. So that's the whole point behind the experiment, is to figure out the heat capacity, which is C. Okay, so that would be the amount of heat lost. This is exactly the definition of the heat capacity for the metal. This would be the Q, the heat lost by the metal to the water in the styrofoam cup, or gained by the metal from the boiling water, divided by the change in temperature. Okay, and what was that change in temperature? Well, we are told that you put it in boiling water, so that puts it at 100 degrees, and then after a minute or so you transfer it to a styrofoam cup at 20, and then the temperature goes to 24. So that means the lead now is at 24 degrees, the metal. So that means this is 1,000 calories divided by 100 minus 24. Okay, and if we divide these two, we get the C for the metal to equal 13.2 calories per Kelvin. Remember, this is not per unit mass because I didn't use small c, I used capital C. This is the heat capacity. Okay, in part D now it says if the mass of the chunk of metal is 100 grams, what's the specific heat capacity? So here it's asking about small c, and as I explained in part A, small c is capital C divided by m. We just make it per unit mass. We unitize it to a mass content. And so here this is just 13.2 divided by 100 grams. So this was calories per Kelvin. So now it becomes calories per gram Kelvin. And so Cm, this is the C for the metal, is equal to 0.132 calorie per gram Kelvin or Celsius. Either way, we used Celsius here. We didn't really change. The change would be the same. so it doesn't matter. Okay, so this would be the specific heat capacity of the chunk of metal. This concludes this problem.